I'd be fine starting with the open questions and just getting into it.
Okay, cool. So thanks everybody for joining. I would love to move forward with this proposal. Even Ryan then said that it would be nice to get that in. But first we need to understand what the API will look like, what we want to actually finalize and how it will look like. And during the last half a year, we collected most of the floats, and I think we are in a quite good shape. Recent discussions, I have collected the open questions as I see it. If anybody else see anything else, any other open questions, please free to add it. I would like to go through with the current ones, which is there in the doc. We have already discussed this with Ryan in Slack, but since then I have seen one of the variants functions getting public in the data writers. So basically the question is how we will handle variants when we are using the readers and the writers. When we have a variant and we have variant shredding, then we would most probably like to access the columns and read the columns themselves directly into the object model of the engines. For example, in Spark, we would like to have a specific, most probably for writing as well, we will have a specific column for them when we are writing. We've been discussing this with Ryan. So that probably objects input and output scheme defined. This is the schema we expect the reader to get the input, and based on that schema, we could generate how the variants are shredded from a variant Iceberg types. And this was how we discussed this, and this is why we, or it was I who had the input schema and the output schema to the APIs for the readers and the read builders and the write builders. This contradicts with the current situation where we have the variance shredding function, which basically just says from this column, from this ID, column ID, get this column name and use this type for writing out the data to a file.
So I'm not sure that it's in conflict with that. So I would add a little bit to the schema discussion, the engine schema side as well. There are a few areas where the engine schema, like knowing what the engine is going to pass you, is a really handy thing to pass through. So for example, cases where the engine has a smaller integer representation, like Spark, so you can have an int8 or an int16, it makes a lot of sense to be able to know that something's coming in as that and then handle it without like wrapping rows before they come in, because that ends up being quite a bit of like glue code. So it's good to have that. And then the idea was also that the engine can specify both incoming shredding and outgoing shredding. You're right that currently the Parquet builder basically has a callback that says, hey, here's a variant column. How do you want to shred it? I think that the builder could actually do that, right? We could have, you know, the Parquet integration could say, okay, well, I'm going to take the engine input, you know, keep track of how that was laid out, and then actually return that same shredded representation to Parquet. Because all of those things are sort of co-located in that write builder. So I don't think that it's going to be I don't think that it's in conflict necessarily. I think that you would have a builder that accepts the engine representation and the shredded form, and then translates that using the Parquet callback.
Basically translates it to another shredded representation?
The Parquet shredded representation. It's also, that is also going to be responsible for creating the builder, right? So the Parquet write builder also currently depends on the engine schema and the incoming Parquet schema. So we're going to also need to align those things. Same thing on the read path. If the engine is asking for a particular shredded representation, we're going to need to build readers that produce that engine shredded representation.
So basically, what we are suggesting that we have a shredded representation in the Parquet file, but we could request and could send a different shredded representation to the writer and the reader, and it would be the responsibility of the writer and the reader to consolidate those and convert those if necessary.
Yes, and I think that for the purpose of this discussion, for the file format API, what we want to do is, basically the inner file formats schema is totally hidden, right? And we want to keep it that way. So really what we pass into these builders is the engine schema and the Iceberg schema. And then everything else is handled within the builders. So I think that actually works quite well, right? And that's why I'm saying we don't really need to change the way that we configure the Parquet schema, although we could, right? We could change the way that we build the underlying Parquet schema for shredded data. This API doesn't have anything to do with the inner Parquet schema. Well, it doesn't directly influence the inner Parquet builder or Avro builder. So I think that we can change that much more easily.
I'm not entirely sure I get you at this point. So basically, what the current change did with this shredded function is expose this function on the data file write builder.
I think it should probably not. I think what we should do is accept the engine schema, accept the Parquet, or sorry, the Iceberg schema, and then all of the rest of it happens internally. We can always add something later. So if the engine schema is, say, here's a binary variant unshredded, then we can always expose some way of saying, hey, please, if you support shredding, please shred this. But I don't think that we're actually going to need to use that. So I would probably just say, for now, to unblock this work, let's just go with the engine schema, the Iceberg schema, and then the actual file format schema is internal to the builder.
Yep. This is what I think as well. So basically, we don't expose the variant shredding function outside of the file format internal API.
Yeah, unless we come back and in the future say, oh, hey, it turns out we actually should have done that, or there are situations in which the engine does not shred, but we do want to shred. We can figure that out later. But I would much rather have that be a future work thing rather than trying to figure it out and block this work based on how we want to shred variants later.
Cool. Anybody else? Any ideas and suggestions? Cool. Then I think we can move forward with the second question, which was whether the new builders should be generic or non-generic. With this, so after the previous decision, now we have two parameters, two generic parameters for the writers and the readers. One is the for the writers, one is the input, and another one is the object, the engine schema, which is the input also for the writer. For the reader, we have the same situation. One is the output, and one is the schema of the expected data. So I think so. With the input and the output, I might be inclined to follow the previous patterns where actually the caller will decide what to do. But with the engine schema, it is very specific for the engine, for the object model. So I think the best solution is to use the having generic types in this case.
I think that it makes sense to parameterize by well, I could be convinced that it's good to parameterize by the schema type. So basically say, okay, I'm a Spark. I think it's good to think about what this means for the API. I am a Spark plugin. I expect a struct type as the engine schema that gets passed in. So registering that way, having some type safety around that, I think is okay, as long as that type safety is actually valuable and used. So if we have to recover that type, then it's a lot less valuable. So basically, like, what happens to that type when we register? Right? If you register something, are we going to have to register and put it in a hash map by that type in order to collect it back out that way? Or are we just getting a builder and then saying, okay, we'll cast it to a type that accepts cast it to a builder that accepts a struct type? Because if you're casting it to recover the parameterized type, then it's not really buying you all that much. Because you're probably going to want to do it.
I understand your point. On the other hand, what I see is when you are actually start using the readers and writers, it's very useful if you know what you are passing it to, and not just objects or whatever, but actual types.
I agree. It would be nice to say, hey, I want to build, when you're calling into this builder, you say, give me a builder. It should accept a struct type as the engine schema. And then when I call set engine schema, it accepts a struct type and everything, appears to be type safe. It's not actually type safe, but I think it is nice to at least have that type parameter. So I would be fine having a type parameter here and saying, like, okay, this is a builder that accepts a struct type for its engine schema. But I think that we should not over-index on type safety here. So like, if we're just going to cast in order to line up all the types, that's great. We can do that for at least the engine schema, but for the output type or input type, this is like the type of row that is produced or consumed, I would follow what we already do with the builders, which is we determine that type at build time, because we're already losing it and then bringing it back anyway. So I would probably say follow the pattern of the current internal data and all of the existing builders. And
what is
one of the reasons why I would do that is to be able to directly reuse the builders.
That's an interesting question, because if we decide to use at least one generic parameter, then we lose that possibility.
We lose what possibility?
To directly reuse the current readers and writers, because we will have at least one generic parameter. So even if we decide that we only use the schema stuff, then we still have a class which is parameterized instead of non-parameterized previously. At least.
So not necessarily, because the engine schema type is not passed into the Parquet builders. So this would be a parameter on the wrapping data builders. So, you know, you've got the inner Parquet builder that, you know, basically accepts a thing, however it is built. Currently, you know, we have some flexibility around how you build the writer. Then you have the wrapping builders, right? So you've got the data write builder, the delete write, the position delete write builder, and the equality delete write builder. Those things, those builders need to know about the engine schema, but the inner Parquet or Avro write builder does not.
We expose those also with the appender and reader directly exposed at this point. At least on this current API, we directly expose not only the content file builders, the data file equal to the position delete file builders, but also the appenders. Specifically, Flink uses those for writes.
Oh, how does Flink use them?
Flink doesn't use really the data file builders API. It still uses the appenders directly.
Okay, well, I guess then that's a question of, if you're going through this API, do you get the option of using the data file builders, or should we design this API assuming that you are using the data file and delete file builders, right?
Well, I think Flink still on the using the old interface, so potentially Flink can move to the new interface, well, even the exit file writer, actually.
Yeah, exactly. So I would be concerned about like creating this new interface and then saying, well, you know, Flink doesn't use it, so we're going to plumb through something else. JP?
Yeah, I think it makes sense. I think if we push for a new API, we should at least encourage the other components to use this one. Else we're gonna have something, you know, pretty scattered and not equivalent. So yeah, if we are pushing for that, definitely Flink should update to this API.
Just to be clear, Flink using not the old in the plans, as it plans today, it doesn't plan to use the old API from Parquet, but the directly plan to use the new write builder and read builder APIs.
Well, so
sorry,
I'm not sure that I would agree with, if you're saying that we want to plumb the old builder through so that Flink doesn't have to use a data file builder or a delete file builder, then like that's not really using the new APIs, right? It's still using a direct builder that creates a file appender instead of a data file writer.
Okay, I get your point. I'm not sure that every other external engine is also using the data file builders and the corresponding APIs. But let me add one more thing. The read builder API is also directly exposed, and it is exposed because, for example, with the vectorized readers, we need to add additional stuff there, like the delete, how does it called, delete filters, for example. I'm not sure you remember, but currently the delete filters are directly pushed down for the vectorized readers. and those are filtering out stuff before the data is exposed through the vectors through the API. So
Okay.
for that, I also needed to expose the internal read builders.
Don't we already have filter methods on the read builder?
We removed them because because of the review. During the reviews, we decided to remove them because it is only used by the Parquet. So we said that, okay, since this is just Parquet, probably we should Parquet vectorize, not even Parquet, just Parquet vectorized. So we just propose have an interface that this is filterable or something like that.
Okay. I mean, I think it makes sense to have a, optional interface provided that says, hey, you can push down filters. Where I think we're kind of going in potentially the wrong direction is saying that we just want to, support all the existing cases. Because I think what we're defining here is an API for doing things the right way. That is where you can register these builders, use them no matter what underlying file format it is, and things like that. And so making that API larger than necessary because some engines weren't already using, the data file builder or the position delete builder. So just saying like, let's have more builders in this API. I don't think that that's going to be a good decision for us long term. We want to, make this API as small as possible. So I would definitely say we want to, on the build path, or sorry, the right path, we want to say you need to be using, if you're going to use this system, you should be using data file builder, delete file builder, and so on.
Okay, and for the read file builder, we will duplicate the API and say that this is the external and this is the internal interface.
Well, for the read side, I would say we have probably one read builder, and that we can use extension interfaces like supports filtering to add that push down. And there's also, no reason why you can't also support filtering on like Avro or something. So, making that something that is generic and can be used across file formats, I think is still a good thing. We just need to think of the right way to gracefully handle formats that do or do not support, or sorry, object models that do not support that.
No, so this is delete filtering and not filtering just for the client.
Oh, sorry, the delete filtering.
So
you mean because you can push down the DV?
Yes, for the vectorized read, it is worthwhile to push down the delete vector because probably we're just returning an empty delete vector with everything filtered out from that.
Yeah. I mean, we could also, it's the same thing as like a normal, supports filter sort of optional thing. So you might have a file format that, does not optimize push down like Avro, right? There's basically nothing we would do in Avro to support push down. Or at least in general, we would want to push that responsibility to the engine because the engine's going to vectorize and run filters a whole lot more efficiently. I would say the same thing for pushing down DVs, right? So they're on the read path, there are just capabilities that these readers might have.
Okay. Also, there are plenty of cases when we just want to actually write out some Iceberg files, and we don't really need the metadata for the delete for the what we are collecting for the data files. We don't want this API to support these cases.
I'm wondering what those cases are because I believe that engines should be creating delete files or data files. So what are the cases where we are where engines are producing files.
GB?
Yeah, if I may, I think that the data file API should really focus on data file first. I mean, everything which is not pure data file, it's the responsibility of the query engine, right? Like the delete vectors and all this stuff.
Okay, this will make the migration of testing quite problematic, because
Okay.
in testing we use this extensively.
Sorry, what do we use extensively in testing?
Just creating files without the metadata.
Okay. Well, in that case, though, is it a problem if we do create the metadata?
We don't have the information at hand to create the metadata, like partitions and schemas and what schema we have, but partitions and partition specifications and stuff like this.
But in those cases, aren't we just creating unpartitioned files? I mean, I'm a little skeptical that we need that, but I you know.
I mean, we can rewrite all of the tests to use this stuff, but then it will mean that we are rewriting all of the tests, and it will be very hard to follow.
Okay, so I guess there is a you know, testability question here. I would think this is similar, right? If we are introducing a new interface, you know, we want engines to use the recommended interface rather than plumbing through an older interface for them to use directly. I would say the same thing about tests, and it's probably even more important because we don't want tests to influence the interface that we choose to expose for, you know, real workloads. So we can, you know, potentially what we could do is have some safety valve for tests only that you can, you know, go and call and get the original builder. Or, you know, maybe we have a secondary API that just exposes this that lives in the test module. But I would say we definitely don't want tests to dictate the API just because it's easier to maintain the tests. We should likely, you know, start rewriting the tests. And so this is, I think it gets into sequencing, right? We want to introduce the API, you know, implement that API with Avro and Parquet and Orc, and then move over, you know, a few engines, Spark and input formats. And, you know, maybe Flink takes a little more work because we want to get it on the new API. I would not say that we want to expose more API surface area just to, you know, either have tests, to reduce refactoring in tests, or to get engine implementations immediately on this. Because the engine implementations can continue to support Avro, Parquet, and Orc directly until we can get them moved over.
Okay, cool.
Sorry, Stephen, you've been waiting a long time.
Yeah, just a quick question. I know the new API Peter is working on can be used by engine, right, to write data file, delete file. The internal data, would that also move to the new API? Let's see if it's ready or no.
I think probably not, but I don't know why it wouldn't be able to.
It has a different requirements for the reader and writer APIs. I'm not sure if we do that,
You're right.
we have the class, root class, and friends.
Yeah.
Okay.
And
Yeah.
so I guess you're right. This is because we use internal data to work with metadata files instead of data files. There are things in the internal data builders that we, you know, that we need. So we have the ability to map directly to a struct-like class, as well as like the delete file or data file metadata. We won't be producing for those because we're actually producing metadata files. Or sorry, yeah, manifests. So yeah, I would probably agree that we just hold off on and have internal data for internal data, and then these for our public API.
But I saw one of your comments, we want to be able to reuse the write builder and read builder from the data.
Well, and actually, internal data currently wraps the existing read builder and write builder.
Okay.
So if we also wrap the existing read builder and write builder, we'll actually be doing basically the same thing.
Okay, thank you.
Okay, so basically the question is, do we see any value in actually having, so we discussed that we would like to remove the direct appender builder part of the API. From the format registry, it will not be, we will not expose the write builder themselves, just the data write builder equal to write builder and positional date write builder. And but we do expose the read builder. They are basically the same internally and externally. And we will need to think if it is useful to expose the schema type on the registry and on the builders. So I need a little bit time to think about this, because this directly influences the next step, how we would like to deprecate the old readers and writers, and how we would like to implement the readers and writers. Because if we have the types, generic types, then we need to create the new class which wraps the old class. If we don't introduce types, we might be able to play around with the methods and deprecate, create new, and finalize that all of the writers using the same methods in the end. To be honest, I'm not even sure that. So we have to go through the list of the methods. There are plenty, and many of them we would like to remove. So probably even in this case, it would be better just to create a new class which wraps around the original implementation and parameterize that correctly.
So I think one of my concerns here is that this is changing too much, or you know, sort of getting into a bit of scope creep. And the two areas that I would point out are renaming methods, you know, renaming builder methods, and also the changing how the output or input type is parameterized. Because I don't think we're actually getting type safety. We're still erasing that type when we send it through the registry. And I don't think we would want to jump through the hoops to not erase that type. Then, you know, you're basically casting to the requested type from the client anyway. So we may as well keep that at build, keep that cast at the build method, rather than adding a new type parameter and needing to replace these classes. And then, you know, the same thing with the method renames. So both of those things seem to be the motivation for creating an entirely new builder at the file format level. And I think we should try our best to avoid doing that. It's just, you know, a lot of code duplication and a new interface that gets deprecated.
Just a quick question. When we talk about the registry, are you talking about the internal data registry currently? Like,
no, there's a object format register, model format registry, format model.
Okay, is that proposed, or is that part of it right now?
That's part of it right now.
Oh, okay.
Or sorry, proposed.
Oh, okay.
So like Parquet, you've got the Parquet write and read builders, And then Spark registers a internal row write and read builder and a columnar batch write and read builder. And then you go in through the interface and say, I'm looking for columnar batches, or I'm looking for internal rows, and my format is whatever the format of this file is. That looks up the correct builder in the registry and then returns that builder. So we're looking to get, I think, minimal changes on top of the existing set of things, and sort of clean up that area.
Okay, I would like to show you, I collected all of the method names and everything we have. I'm not sure you can read these ones. The green ones are the nice ones. We have those, we don't need any renames. Light greens ones we didn't have previously, we just add those. But the red ones which we are removing. So for example, with Parquet, we have case sensitive without parameters, and we have case sensitive with parameter. We are keeping only the one of those. Filter records, it is called filter records here. It's filter. Probably we could change that one. Oh, sorry. We have filter records for Parquet and then filter with expression. So these are okay, but for example, set, we have set. In ORC, we have config. I have suggested to use set. We don't have the set for the maps.
I think we do, though, don't we?
These are the readers.
The reader builder. Okay.
On the writer, we have set all.
Okay.
On the reader, we don't have set. And
so, oh, okay. So the one I'm thinking of is this line 34 down here on the right builder.
Yeah.
Where we have set all, set all, set all, and then suggested set.
Yeah, because we have set on the Parquet, we have meta, which have meta. So it's very, very strange to create an API which is inconsistent itself.
So I think there are some of these things like row 35, right? Meta, and then
metadata.
The orc builder does something different. I think it makes sense to use meta, right? And that would be fine.
This one is also a bit questionable.
Mm-hmm.
I get this from the reviews that should be not with but name mapping because it's more consistent. It is a question how we build. This is the new API, and we would like to have it is as it is and without context. We are saying that this is the new API and it looks better than this, or we accept small changes, or we say that we want this one to keep.
I mean, I think that we should, in general, use minimizing code changes as the guide. So if 2 of 3 or 3 of 3 existing builders use the same method name, we should continue using that method name. And then consistency across the builders. So if we have a set all method, continue having a set all method. That sort of thing, I think, makes sense. Or, if we're talking about having no bulk set from map method, then we can continue not having a set from map method. I probably would not. I would, like I said, minimize the changes that we're introducing here.
Okay, cool. And if anybody else thinking differently, because I get these changes from review comments. It wasn't me who introduced it.
Sorry.
I don't care, to be honest, in this detail. I just want to hear that if anybody has any objections, then I will revert back to the original names. And if you take a look at these red ones, these are the interesting things which for example, for set root type, set customs types should be there on the Parquet write builder, but it shouldn't be there on the API. It is, and some of these are basically deprecated stuff, which we soon need to deprecate through this process, I think. And the question is, do we want one class implementing the two different interfaces and having all of these methods in one place, or we want to spread those out in multiple multiple classes, which definitely describes what is exposed in what direction. Stephen?
You're still
muted. Can you mute?
Sorry. In the PR, can you call out after the discussion? I'm sure you're going to update PR. Maybe you can call out what method that made a change compared to existing API, so make the review a little easier to see what are the rename, for what reason, or what are the removed, what are the assistant. Just call it out.
Yeah, I think a lot of this is probably like, if I were to see a brand new API with with name mapping, you're right. We'd probably say, hey, what's up with that? But if we're trying to minimize changes, and sorry, I think that's multiple reviewers over multiple months causing a lot of churn. So thank you for dealing with that confusion and pain.
Okay, so that's method names for us. There was one question which is coming up again and again during the discussions with different direction as well, that what to do with re-registering the same file format and object model, object type. What should we do with that? First, it was like, okay, we can override it, but then this could cause inconsistencies or surprises if somebody adds a jar which behind the scenes changes that. So it is currently in the current form, it is rejecting changes to the if there is a new registration comes from the same file format and same output type, then it will reject that stuff.
I'm in favor of rejecting, I think. I think that most of this is not intended to allow you to plug in an alternate implementation. It is intended to make it easier for you to read and write files without caring about calling into some code path directly. So I do think it would be confusing if we made it so that, some other library could override your, Spark write builder for Parquet. That would be kind of strange.
The only thing I'm concerned about from just like a environmental standpoint is people often get like multiple jars, in their class paths. And so that I think is probably a good argument for rejecting and signaling quickly that like, hey, you may have registered because like EMR had an older version, or you just happened to pick up both like a bundle and a non-bundle that happen to be different versions, and that can lead to really strange problems, right?
I agree.
Steven?
Oh, you're still muted.
Mute again.
Sorry. Yeah, I was thinking a lot of rebinding, because I'm thinking in the Flink integration case, I don't know, Peter, if you think about it, how would that registration initiated? Because let's say if Flink job restart, it's still the same JVM process. If the binding is initiated during the restart, then we may need to be rebind. So that's something I don't know.
As long as we can tell it's the same thing that you're rebinding, that's different than binding a different one. I'm not
Yeah,
sure.
it's the same thing. I'm talking about the same thing. Yeah.
Yeah, because I think you're gonna have the same problem with Spark, effectively, like on the executor side. You have multiple tasks coming up, depending on when and how the static registration happens. There could be multiple.
Because the current PR, even the same rebinding is not allowed. Same thing rebinding is not allowed. It just it's not now. Yeah.
I think we can always add something to say, okay, what is the class that was registered? Or sorry, actually these are anonymous functions, but we can probably detect and then just dedupe. But what I would do is probably say, we can detect that it's the exact same thing, and then we deduplicate the registration using the existing one.
Yeah.
Okay, so basically we should try to detect and dedupe. Okay. These are okay, packaging. That's again, this is interesting. The classes have been moved around in several cases around the code path, but it is sure that they need to be at least in the core module because of the dependencies. In what packages are there? I lost interest in that. I'm happy to do whatever the community decides. Currently, some of them are in the I/O, the API stuff, the reader and the writer and the format model stuff, and the registry and friends are in the data module.
Okay, so I/O is generally used for low-level I/O primitives like input file, output file, and our stream implementations and things like that. The data package, it was created and has been used for our internal data abstractions. So struct-like, record, and so on. So I would probably not use either of those, which just because
I understand
we're mixing into modules that have existing purposes. So if I were thinking about this from the start, I'd say maybe a formats module if we want to place it in its own module, or just in the org Apache Iceberg module, because that's where a lot of this stuff goes. We tend to just put a lot of stuff in the root module, and that's generally okay. Dan, do you have an opinion? I saw you.
Well, I don't like the proliferation of just like packages everywhere. The data one, I think, before initially it was like data format, or there was a new package that was proposed. The data package doesn't really have a whole lot in it. There's not a whole lot
there. But that's because it's in the data module. Yeah. I'm not. I think that one's better than I/O, and I would not like block putting it in data. But
I'm not opposed to having a format or formats package. I think the problem with the top level package is that, one, there's a ton that's in there, and it also exposes a lot of protected behaviors that are in that particular package. So like, if we don't need any of that, why not put it in its own place? I mean, the top level one is like quite packed full of just lots of stuff.
I would love to avoid that.
I agree. Let's avoid the top level. So then either data or formats or format. I think, yeah, whatever you guys.
Who wants what? Both.
How many classes are we talking about? Like size, I think, does matter. Like, I don't like packages that only have like 2 classes in them, right? That's not super
I think
helpful.
it's 5 or 6. It's at least 3 builders implement 3 builders. They call the format builders, and then
The implementation.
yeah, the registration, the implementation classes, and yeah, so there's a fair number of classes, like
7,
7,
8, yeah. Like this.
But if we go to Steven's last question, was that do we really need to have the interfaces for the data right builder, equity data right builder, positional data right builder, or we just can have classes for that and avoid just generating interfaces and new classes?
when in doubt, use interfaces, I think, because it's painful to try and move to an interface. I mean, we just did that with the position delete, right?
Don't tell me.
It's like, oh no, why do we use a class?
So I was just looking to see, and Ryan, I think you're actually wrong a little bit. All of our internal data classes are actually at the top level package. The generics are in the data package in the data module. Record is in the API. That's the only thing that's in the data package currently in the API. Then we've got 3 classes in the data package in core.
Okay, so the Iceberg generics are data, which is what I thought I said.
Yeah, I thought you said internal data was, that's where we
okay.
keep all our internal data.
Well, actually, those 2 things kind of grew up around the same time. So like struct-like is both of them. But okay, yeah.
Yeah, but struct-like I think is the top level. Or in types. That one's in types.
Okay.
I think the data has some of those Avro class. In the core module, the data package have some of those Avro class.
Yeah.
Reader, writer, those things.
Hopefully this will also allow us to like separate and take Avro out of our APIs. That's a good thing to do for like a 2.0 and just remove exposing Avro things.
Mm-hmm.
I don't think that we expose them in API though.
Yeah. Regarding the builder, yeah, because typically I don't know how OpenSea builder has an interface. Yeah, builder typically you're building something, so typically you're the concrete class, you're trying to build something. It's not like a position delete is yes, that interface makes sense, but I think builder have an interface. I found out a little bit kind of weird to me, but anyway.
Yeah, so I was just to be clear, I was wrong. Struct-like is not in types; it is in the top level. So.
Okay, I created those as interfaces because this is how I usually build an API. I create an interface how I would look like to be, and then start the implementation later.
Interfaces are much better. One, because it's hard to move to an interface, and interfaces are composable, whereas abstract classes are not. And so there are a number of places where we can get into trouble where when you're actually building it, you want to leverage 2 different sets of functionality, and you can't because it's abstract.
Composition is actually a very strong argument for it.
Kevin?
Yes, hi. I just want to mention we're going to get kicked out soon.
Yeah.
Actually, we have 6 minutes.
But actually went through all of the questions.
This was super productive. Thank you for setting it up, Peter.
Yes, 100%.
And thank you for working on this. This is going to be really awesome to get in.
Yeah, thank you very much for coming. I will definitely work on that to move forward with all of the suggestions we discussed here. It will not be tomorrow, but I will do my best.
Yeah, these meetings are all very productive. I think this is bi-weekly at this point, and then we can adjust as needed.
Cool.
Hopefully after 2 or 3 of these, we'll just get it in.
Yeah, I was joking with Peter. I was like, hopefully it's not forever.
Yeah, and please feel free to comment on the letters and then the PRs. Don't take a too deep look at the proof of concept implementation at this point. I won't really plan to implement that. I think we will start from scratch this was there just to make sure that we are able to implement these interfaces and there are no unseen blockers. I will move forward with going through all of the API stuff and see how it looks like. Thank you. Thank you for all of you.
Yep.
See you.
Thanks. Bye.
See ya. And I'll put this up on YouTube too.
Cool. Thanks, Glenn.
Bye.
Bye.